Okay, I think we're going to go ahead and get started today. So first of all, thank you to everybody carving out some time to jump on this call. We know everyone's got a busy schedule, so we appreciate everybody hopping on this call with us today. So SD-WAN, it's been a buzzword in the marketplace recently, and we're going to do some kind of in-depth use case studies of it, industry-specific qualification and implementation. Now, during the presentation, we're going to have some time dedicated at the end of it for Q&A, so please go ahead and hold on to your questions until that time. Write them down. They're all good. We'll answer them at the end of the presentation. So before we go ahead and dive into the meat of this subject, I want to do some brief introductions of both Freewire and the presenters today. So we're going to have two speakers. It's going to be myself, Derek Johnson, the Director of Business Development, as well as Elliot Schwid, our sales engineer, who has been leading the charge with our various deployments and implementations of the SD-WAN solutions we house to both the end clients and partners alike. So a little bit about Freewire, just to give everybody some background information on what we do over here. Freewire has always been centered on managing networks and deploying optimal solutions, constantly staying on the cutting edge of technology. And we really believe that if we continue to grow and develop with new inventions, new technologies, we'll always be able to deliver the best solutions to our customers all the time. And since we are so focused over here as a premier MSP at network resiliency and optimization, it was only a perfect fit that we migrated into SD-WAN. Now we know SD-WAN has been thrown around in the marketplace a whole lot recently. It's gaining a lot of traction. It's the recent latest buzzword. You know, is it telecommunications? Is it networking? We're going to go over all those things. But really, SD-WAN has only been a viable product to deliver to end customers now for about 3 years, meaning that, you know, finalized products have only been available in the market for the last 3 years. And of those 3 years, Freewire has been vetting, observing, and deploying and implementing various SD-WAN solutions to end customer networks. So we were early adopters to this solution. And being early adopters to this solution has given us a deep wealth of knowledge to draw from, as well as a lot of experience when it comes to both a variety of different SD-WAN solutions, as well as how they implement into a variety of end customer networks, as well as industries. So we got a lot of experience and a lot of knowledge that we're going to be talking about today when it comes to both choosing and deploying SD-WAN solutions. So SD-WAN at a glance. You know, before we get into the meat of the presentation, I wanted to deliver a definition of it. You know, what we've seen recently is upwards of 50 different solutions on the marketplace. You know, 50 different companies have come up with their own solution and have plastered SD-WAN solution. You know, how can every single one of these SD-WAN providers have an SD-WAN solution? So what we at Freewire have developed is really a very straightforward definition to what we consider to be an SD-WAN solution. And in order to be considered a software-defined wide area networking solution by Freewire, the solution has to have 3 pillars, or these 3 main components that we have up on the screen. So component 1 is that the solution on a fundamental level does optimization of public internet connections or optimization of transport methods in general. So the solution has to take existing bandwidth and enhance the quality of that bandwidth so that you end up with something that you'd expect to see from dedicated fiber, whether that's best effort internet connections or layer 2 transport. The system has to enhance that and optimize that connection. We will see that this takes the form in a variety of features and techniques from different SD-WAN providers. Some use forward error correction, some use aggregation and bonding, some use intelligent traffic steering, and some use all three. But optimizing connections has to be a centrally vital component to the solution. Now, component 2, to be considered a Freewire SD-WAN solution, is that the system has to incorporate a method for site-to-site communication. So if the solution only does load balancing and failover, but doesn't actually have a method to incorporate site-to-site communication, then it's not going to be considered an SD-WAN solution. Most commonly, we'll see that automatically generate VPNs either in a full mesh network configuration or to a hub and spoke-like configuration are going to be what SD-WAN providers deploy, but there has to be that option of site-to-site communication. Now, the third point to be considered an SD-WAN solution by Freewire's definition is that all of your WAN has to be easily manageable. There has to be a centrally accessible platform where the organization and individual has the ability to easily log into, monitor and manage your entire WAN, and delve and dive into individual branch levels, as well as get more granular from there. So really 3 main points. 1, optimize internet connections, or connections in general. 2, overlay site-to-site communication. And 3, have a centralized management platform that's easy to use. Now that we've defined what SD-WAN is, we can break it into 2 main categories. And there's 2 main systems that all SD-WAN companies are going to fit into. The first one is going to be the POP/gateway system. And from a high level, it looks like the following. The SD-WAN providers, the actual company that develop and manufactures the SD-WAN solution, owns and maintains their own infrastructure of gateways and POPs that are spread out over a geographic location. They are then going to leverage this infrastructure to deliver their SD-WAN solution to on-premise equipment at the end customer's location. So the end customer is going to have a variety of locations, and these locations are going to communicate back to the geographically closest POP or gateway. And that's how a POP/gateway system is able to deliver their SD-WAN. Now, the second category that the rest of the SD-WAN solutions are going to fit into is what we consider internal network-based. So these SD-WAN systems are going to, at no point, ever leave the end customer's network. They are going to solely and exclusively reside on that customer's network, either in a full mesh configuration or in a hub and spoke configuration. Sometimes we'll see that a POP/gateway system almost is a microcosm in the internal network-based solution, but at no point are they ever going to have to leverage a third party's gateway system to deliver their flavor of SD-WAN. So really, we've got the definition now of SD-WAN and the 2 main categories that all SD-WAN solutions are going to fall under. So then, what's the attraction to SD-WAN? Why is it gaining attraction in the marketplace? Why are we seeing this kind of snowball effect recently within the last year? So many companies are transitioning over to it. So many companies are starting to try and implement it. You know, what are the features and benefits of it? Well, over here at Freewire, we know that there is a laundry list of features that come with an SD-WAN solution. And we have chosen a few of the most important features or key benefits to put up on the screen that you see in front of you, but there's a laundry list really that SD-WAN has to offer. So first and foremost, let's talk about connection optimization. You know, why companies are transitioning towards this. Well, we know that a centrally important component to be considered an SD-WAN solution is that there's connection optimization. We touched on that in the last slide. But what does this really mean? Well, it means that you can take any method of communication and connection and optimize it. And this is going to take the form of a few different techniques. We can see that underneath as the intelligent traffic steering. Now, what this means is that SD-WAN solutions have the ability to intelligently direct traffic over the best available connections that are plugged into the end customer locations. And the systems are going to inherently know, 1, types of traffic, so real-time protocol, transactional, and bulk. and then depending on that type of traffic, make a decision either on a per flow or per packet basis to steer that traffic over the best link plugged into the end customer's location on an ongoing continual basis. Now, one of the next features that's important to note and why companies love SD-WAN is the site-to-site VPN side of things. So when we talk about networks that are 500 plus locations or even 10 sites for that matter, managing, creating, terminating VPNs can be a hassle. It can be a sticky point for the IT teams that are responsible for setting up those networks. With SD-WAN, all of the profiles are configured and managed in the cloud. And what this means is that whenever an end device, which is pre-activated, reaches its end destination at a branch location and is plugged into the internet, it's going to hone back to either the hub or the gateway, download its profile, at which point it's going to recognize that there needs to be a VPN network, either full meshed or hub and spoke. And it's going to automatically generate that VPN and manage it on an ongoing basis. So at no point does the IT networking have to actually create the VPN or manage it on an ongoing basis because it's an inherent component of the solution. And one of the reasons is the manageability that people are gearing and switching towards SD-WAN. Web-based management. So once you've got a wonderful network all set up, how do you manage it efficiently and easily on an ongoing basis? All of the SD-WAN solutions that we house here at Freewire and that we've vetted and chosen contain a web-based portal where the end organization and networking team will have access to. And this will give them a monitoring perspective of their entire WAN, as well as management capabilities to make on-the-fly configurations, as well as troubleshoot both your WAN at a glance and individual branch levels, and actually dive in further from there to get more granular. So you have a degree of management that you can access from any device that can gain access to the internet. Now, bidirectional QoS. This plays into intelligent traffic steering as well as connection optimization. While one of the central components of an SD-WAN solution is that it actually optimizes and corrects bandwidth, the other side of it is going to be apply correct prioritization. While there used to be a lot of solutions that could apply outbound prioritization, this is one of the first solutions and systems that has the ability to apply that same QoS prioritization on inbound traffic. So really gaining visibility, control, and optimization of both in and egress traffic. Now that is huge when it comes to providing QoS for any type of time protocol or bandwidth congestion control. Active-active solution. Networks have always been designed, if they're designed properly, to have a degree of redundancy and resiliency. We'll have a primary connection with a backup connection or even a tertiary connection for backup. And what will happen is that when we deploy SD-WAN, we'll have an active-active solution, meaning that it's going to use all connections on a real-time, ongoing basis. And finally, hybrid MPLS. SD-WAN solutions have the ability to load balance across both public and private connections. All right, so now that we've gone over the definition and we know what some of the features and benefits are, why it's gaining attraction in the marketplace, quickly, not all SD-WAN solutions are the same. So if we've identified an end customer and we want to, deploy SD-WAN, we need to be careful about what solution to implement because each one is going to have their own unique flavors and set of specific techniques that they utilize that are going to fit better in certain networks, certain industries, and certain customers better than others. We don't want to be putting a square peg in a round hole, which is why here at Freewire we've chosen 4 diverse solutions. So for this presentation, we're going to do a mock qualification and implementation of SD-WAN across 3 different use cases. Each one of these use cases is either going to reside in the retail industry, medical industry, or service industry, so we get a broad spectrum of the different networks that we have deployed to. We're going to address 3 points to these. 1, alleviating operational inefficiencies. This is going to come in the form of increasing ROI, having a positive impact to the budget, as well as alleviating the functional inefficiencies that are associated with standard conventional networking. Then we're going to develop the customer profile. What does a good SD-WAN company look like currently? How is their network configured? What are the pain points of it? And finally, and most importantly, we're going to take a look at what solution we delivered and how it addressed and alleviated those various pain points. So the first use case that we're going to take a look at is called Charlie's Door Handle. Now, this is a retail use case, and it's representative of most retail-specific companies. While we're going to take a look at its unique problems, these problems are experienced across the board in the retail industry. Now, Charlie's Door Handle is the largest door handle retailer in the United States. They currently have 120 locations, and they're located across 20 different countries, 20 different states. Now, what this network poses from the beginning is a high volume of branches across a geographically diverse area. So first and foremost, let's take a look at the budget. This is something that always has to be addressed upfront when we're talking to end customers. Now, Charlie's Door Handle is very bottom line oriented. While most companies and most industries are conscious of their bottom line, certain industries are more sensitive to the bottom line than others, retail being one of those industries. IT networking and expenses cut into profit margins, and wherever and whenever we have the ability to diminish their budget while maintaining or increasing the same level of efficiency in operations is a good thing. So a solution that's an SD-WAN needs to address two main areas. One, it's got a positive impact to the budget, increases ROI, and two, alleviates current inefficiencies. So the customer profile for Charlie's Door Handle, like many retail operations, there is some specific and unique networking aspects and characteristics to Charlie's Door Handle. One, it's got a high volume of branches. 120, it's growing, it could be contracting, but it's changing, but it's a high volume of branches. Two, they've got low bandwidth requirements currently. They are utilizing an MPLS network that for the most part is delivered over T1s. So they're running at max 1.5 meg symmetrical. They've got a point of sale system that is absolutely vital to their business operations. And if at any point during business hours that POS goes down due to connection problems, that means lost dollars for the company. They're running VoIP phones from site to sites. They need to have inventory transparency. So branch locations need to be able to communicate on a real-time basis with other stores to see if they've got that inventory, or with warehouses to see if they've got that inventory if they're ever running low. Possibly they've got an on-premise firewall, but most likely they're routing all traffic back to a centralized data center at HQ, in which there's a large enterprise firewall that's going to do deep content filtering before any type of internet access. So now that we've developed the customer profile for Charlie's Door Handle, let's take a look at the pain points. Well, first, what's probably going to jump out to everybody is MPLS. MPLS has really been cleaning up in terms of how much it's been charging over the last 10 years. And we know that for a standard, over T1, that's probably going to cost anywhere from, on the low end, $400 a month to upwards of $800 a month, depending on the location. So they've got expensive networking costs right now. Communication between sites. When we're taking a look at deploying an SD-WAN solution, how are we able to ensure quality of service utilizing best effort internet connections? These are going to be questions that come up for inventory, for VoIP services. And also, utilizing low bandwidth right now is going to lead to slow file backups and transfer. So that brings us to our point of bandwidth congestion. While in the past, retail locations could get away with 1.5 meg symmetrical for their bandwidth needs at locations, we know that the marketplace is trending towards digital marketing within the stores, meaning that they are streaming music, they're streaming video. They've got applications that now need a lot more bandwidth than previously, and running over a 1.5 megabit transport path is just not cutting it. And what this means is that mission-critical applications such as POS or VoIP phones are going to take second tier to the bandwidth hoggers and thus decrease the inefficiencies of that network. Now, network resiliency. Anytime you're dealing with an MPLS system that doesn't have a backup internet connection, you're susceptible to a single point of failure. So if there's a hiccup within that MPLS network, your entire network is going to feel that. Location changes. As retail operations continually expand and diminish and change depending on the market, new locations, moving locations, and reducing locations are all going to pose the issue of extending a highly inflexible MPLS network to those new locations. Now the solution, enter SD-WAN. What does SD-WAN bring to the table in the solution? Well, first, cost. It's going to reduce the monthly reoccurring if you can replace that MPLS network. Simply because, on average, when bringing in two best effort internet connections and overlaying an SD-WAN solution, you still will come out on a conservative side at saving 40% on your networking budget. Communication between sites. Once we've gotten rid of our MPLS, like I had mentioned earlier, the systems will automatically generate those VPNs to ensure that there is encrypted and secure site-to-site communication with not having the need to actually configure those VPNs. Bandwidth congestion. This comes down to the point of connection optimization, so intelligently routing traffic. So now that you've got all these bandwidth hogging applications that are streaming video and music, the system's going to identify two tiers of importance. One, traffic type. So real-time protocols are going to take precedence over transactional and bulk, as well as any predetermined priority applications, POS systems, VoIP phones, any custom applications that are centrally vital to that business's operations. We are going to assign various priority levels, and thus those are going to get precedence in any type of bandwidth congestion scenario. Network resiliency. No longer are these customer networks susceptible to single points of failure, because when you bring in an SD-WAN solution, best practice is to bring in two separate connections utilizing two separate carriers. And it is very rare that two separate carriers are going to be experiencing the same connection issues at the exact same time. So you're going to have diversity in both connection as well as the carriers. And changes in store locations. How do we accommodate this? Well, one, it's considered plug and play for a reason, and that is that you don't need a specific network to extend this level of standardization that SD-WAN brings to the table to. It just needs any type of bandwidth. So if you open up 10 new branches and you get a variety of different carriers across a variety of different types of connections, that's great. SD-WAN is going to take those connections, apply its bandwidth corrections, initiate its VPNs, and you'll have those sites up and running as soon as you get those connections into the stores. Now what I'm going to do is I'm going to have Elliot Schwid walk you through what a network diagram looks like for a deployment like this.
Okay, so what does the actual network look like after an SD-WAN deployment? So what we've done here is we've done a POP-based network. So we have our edge devices at each site, our edge devices. This is our corporate site. You can see here the corporate firewall, and we also have the data center. So the edge device is now plugged into 2 to 3 dedicated or best effort internet connections. It creates a VPN tunnel from the edge to the carrier POP or gateway, and accesses the internet through the carrier's multiple redundant upstream providers. Now these carrier gateways are also connected throughout the country through these private layer 2 connections, so that you have a consistent routes between your different sites, whereas traditional VPN, your VPNs can change routes based on different carrier routing changes or other issues that might be felt. So what this gives you is a redundant upstream at your corporate site that you won't feel any issues with any of your upstream providers, and it will also mitigate any issues felt by packet loss or latency. Now at your branch sites, you now have very good access to your corporate data center, and you also have a very consistent VoIP quality from site to site because of these consistent routes between your sites across the country. Then how do we manage this is through our cloud orchestration, which is off-site and can be managed even from anywhere across the United States.
Perfect. Thanks for that, Elliot. So now we're going to go ahead and jump into the takeaways of this. So Charlie's door handle. What are the takeaways? One, budget. We've got a cost reduction that is significant from the current networking landscape. Network resiliency. We introduced a level of redundancy that previously was unattainable by using only a single connection or carrier. Network management. The ease of use when it comes to cloud-based orchestration. Expansion/relocation. It's a scalable network deployment. Because everything is based in the cloud, all you need is some sort of connectivity at the site. And once you've plugged in the SD-WAN solution, it's now on your site fully configured. And bandwidth utilization and control. How to accommodate for best effort internet connections. So now we're going to jump into a medical case study, a drastically different industry than retail, but still able to have just as many features and benefits from the SD-WAN solution. We're going to take a look at Smooth Clinic on Demand. So this specific use case has 40 clinics across 3 states, so it's a decently sized clinic, but again, remember, this can be extended to one of the largest medical providers or even the smallest. Additionally, they've got another layer of complexity. They have 5 telehealth workers that are stationed in homes, and this is growing. So the budget of medical procedures and medical operations, we know, is robust. And we know that functionality and network uptime come before making a decision based on price. However, everybody is still conscious of the dollars that they're spending. So this solution needs to be functionally optimal and still come in at a reasonable price tag. So what does customer profile look like for a medical operation? Well, they're going to require multiple levels of redundancy. And anytime you're dealing with life and safety, you're going to expect that the network's going to be inherently redundant to a degree, a little bit more complex and robust than most other industries. So what you're looking at is most likely an MPLS network, sometimes maybe even 2 separate MPLS networks that are going to bring in the various clinics as well as backup DIAs, sometimes in the form of multiple at each one of these locations. There's also going to be some form of rudimentary failover, maybe BGP, or even some form of predetermined static load balancing. Additionally, we're going to take a look at now how these companies are accommodating network changes to be able to take a look at the telehealth opportunities that they have and bring them onto their network. These companies probably also have some application prioritization that they have built into the systems, but most likely not in an elegant way. They've got robust firewalls at each one of the locations, most likely. Some will come back to a centralized data point, but we've seen both in the medical world as having on-prem firewalls as well as everything being backhauled to a central point where then it is filtered from a firewall. All right, pain points. Number 1, let's take a look at the remote telemedicine deployments. This is a trend in the medical industry right now that will only continue. And what this does basically is it's got 2 main facets. One, customers or employees of the current medical provider are going to go home or go to remote locations where they're going to need to be able to have real-time video sessions with clients. Now what this gives us basically is a situation where either there is a lack of sufficient bandwidth, meaning you just can't get enough bandwidth to the location, or a lack of quality bandwidth for these real-time sessions. Network uptime, incredibly important for life and safety industry. MPLS is very reliable, and you can usually count on it, but there are going to be those hiccups, and we know that any network is susceptible to something. So those hiccups could be in the middle of a life-threatening situation. So anytime you have the ability to add even another layer of redundancy is going to be a selling point for these types of operations. Now, inflexible network. As with any industry that's growing or retracting, MPLS is very difficult to extend to new locations. The build-outs are going to be costly as well as lengthy. They're going to take sometimes upward of 6 months to bring just a single site back onto that network. Now, what does the solution look like? Well, enter SD-WAN again. So let's go through the pain points. Real-time video consultation at these remote locations. These can either be employees of the current provider, or they can be a partner program that that provider is extending services to via telehealth or telemedicine. So what these systems do is, one, correct the bandwidth. We know that most residential bandwidths are going to be lacking in the quality of their bandwidth delivered and cannot actually deliver good quality video sessions, as well as lack of bandwidth. Now, one of the great things about SD-WAN is it can use any type of bandwidth. So what we have seen as the most common practice is that at residentials where they're doing telehealth conferences, they're going to plug in their current wired connection and then plug in 1 or 2 or even 3 4G LTE data cards to get sufficient bandwidth to that location. Then the SD-WAN solution is going to optimize the bandwidth through its traffic steering, bandwidth correction, and aggregation techniques so that these individuals have the ability to initiate real-time sessions without ever experiencing any degradation of service. Now, next is, how do we add a layer of standardization when we're doing these deployments? Well, when we're talking about telemedicine deployments, we're essentially taking a home and turning it into a virtualized branch. So you need to have good quality bandwidth, control, and management. And this is where the orchestration comes into play. IT networking teams have the ability to monitor their WAN, both the branches as well as these remote locations, as if they're in their current WAN from one single point. And finally, network resiliency. This is huge whenever it comes to life and safety, and I can't stress it enough. You can utilize 1 or even 2 MPLS networks alongside of DIA connections. The system is going to inherently, on a real-time basis, monitor each one of those connections and flow traffic accordingly over them. So no longer do you have any sort of BGP required or any loss of sessions because you're using an active-active or even active-active-active solution. So Elliot's going to take you quickly through what an MPLS hybrid or a medical operations deployment is going to look like.
So with smooth dermatology, we had the interesting issue of needing to keep MPLS and keep their advanced security, but adding bandwidth while allowing that security to be maintained at the same time. So what we've done here is we've added our edge device at each clinic, kept our MPLS, but added a best effort or a dedicated internet connection to the edge device. And what this adds is much more bandwidth between sites while maintaining their security and their MPLS. So they have multiple layers of redundancy while keeping their network pretty much the same as it was before, all while adding cloud orchestration where we control how applications are run and whether they're run on the MPLS or if they're run on the internet, over the internet VPNs between sites.
Perfect. So now that we've taken a look at both the retail industry as well as the medical industry, let's go ahead and look at the takeaways before we jump into our services industry. So takeaways for smooth dermatology. 1, standardization. This is vital for any networking team that wants to be able to efficiently manage and deploy a network. So SD-WAN really brings a level of uniformity and standardization to the end user experience. So any type of virtualized branch or new branch is going to be performing at the same level as every other branch that's out there. Management. It brings a central point where the customer has the ability to manage their network efficiently. Redundancy. Active solutions. There's no longer failover. You don't have a primary and a backup. You can actually bond 2, 3, all the way up to 8 connections in some SD-WAN solutions to create a truly diverse and resilient network. And remote access. How do you accommodate for quick turnarounds when it comes to telehealth workers or bringing on new branches or partner programs into your network? You can do this through SD-WAN, through plug and play, and creating any type of bandwidth that has the ability to go through the SD-WAN solution and thus has the ability to fall into that standardization. Now, finally, let's take a look at our service industry. So this is the last use case that we're going to take a look at, and we're going to have a good understanding of 3 different industries after this. So speedy site cleaners. Now, this is a smaller operation, but again, it can be representative of a large operation. So there are currently 5 equipment rental locations / employee offices. So these are permanent locations with conventional wired connections running into them. They've also got 4 mobile trailers that they are going to send to various job sites for cleanups. This could be a construction company that's got mobile trailers as well. Now, the budget. Well, service industry is going to vary widely in terms of its budget, but one, it is going to be concerned with its bottom line. Much like retail, any type of area where it can have a positive impact, the budget is going to be a huge selling point for them. As well as this budget is going to vary based on the locations. It's going to be standard at those 5 permanent locations, but who knows what type of bandwidth they're going to be able to achieve at these various mobile sites. So the customer profile with speedy site cleaners. They're running MPLS at their 5 permanent locations. They're going to be using a point of sale system there. They're going to be looking at inventory, especially if this is a rental operation, what stores have certain inventory, how they can share that inventory, as well as VoIP phones. They're going to be running VoIP phones over these, MPLS, and they want to do that so they can guarantee QoS. So they've got a pretty standard bandwidth / network for a small service industry. Now, at these remote or these mobile sites that can take anywhere from 3 months all the way up to 3 years, depending on the industry, construction or service, and how long they're going to be there. And these are going to pose quite a bit of pain points. One is going to be, how do I get bandwidth there? Well, they're most likely going to be using 4G LTE data cards, and that's going to create spotty, low bandwidth quality. Maybe they're doing satellite at some. They're going to need to have access to cloud-based applications, email, inventory, anything that's housed in the cloud that's centrally vital to their operations as a business. So the pain points. One, the conventional single point of failure. This is going to be a universal network pain point across every single industry. It's going to be costly and it's going to be susceptible to a single point of failure. The next is going to be unreliable 4G LTE failover or bandwidth optimization at these remote locations / job sites. At one point, one of the job sites may be located in the coverage zone of Verizon exclusively, and then the next job site is going to be located in AT&T solely, maybe Sprint. Maybe they're going to have some overlapping. Maybe it's going to be both Sprint and AT&T, but not very strong coverage. So the bandwidth is going to be varying depending on where these job sites are located. And this creates a lot of pain points from both the quality of bandwidth as well as the network standardization and management. So seamless communication. If these are 3-month job sites, every single time, every 3 months, the networking team is going to have to send out equipment, configure those VPNs, terminate those VPNs, and manage that network on a conventional basis. Access to vital information. So anything housed in the cloud, if you've got poor quality of bandwidth, you're not going to have a good user experience with maybe desktop as a service, Office 365, real-time protocols. It all depends on the quality of your bandwidth. So let's take a look at how we implemented SD-WAN into this specific use case. One, again, like we did with every other industry, single point of failure, we implemented SD-WAN to provide those permanent locations with a layer of intelligent load balancing, efficiency, and removed any single point of failure. Job site access to the cloud. So one of the unique things about SD-WAN is it has the ability to utilize any type of bandwidth. So what we've seen is individuals actually will take an SD-WAN and plug in multiple carriers' cards. So Sprint, Verizon, AT&T, 4G LTE cards, all plugged into the same box. And because of the forward correction tactics and the traffic steering, it's able to, on a real-time basis, accommodate for anything, any type of degradation that's associated with 4G LTE coverage. Network integration from the job sites. Because these are plug and play, all they need is some form of bandwidth. And once they have been plugged in, they're going to use that predetermined customer profile to download every aspect of that network for that specific job site. So no longer does the networking team have to configure each one of these job sites every single time. They just send them with an SD-WAN box that's going to hone in and say, hey, what's my profile? What's the network I need to log into or connect into? Okay, great, I have that. And bang, you're up and running in a matter of seconds. So communication from store to store, again, that automatically generate an ongoing managed VPN that at no point does your networking team have to touch. So what the network diagram looks like for speedy site cleaners is as follows. I'm going to have Elliot run you through this one, as it's got a little bit of a unique feature to it.
So with speedy site cleaners, we had the unique issue of needing to connect to their data center through an MPLS network without putting a device in their core. So what we have is through our carrier POPs, we have a physical cross-connect with their MPLS provider, giving us access to their MPLS network through the open internet. So our multiple internet upstream providers at our mobile job sites create a VPN to our gateway. We have a physical cross-connect to the MPLS provider, giving us access to their corporate data. This is extremely scalable and easy to deploy using 4G cards or any available bandwidth at these remote sites. And again, we have our cloud orchestration to make sure everything is running correctly and perfectly.
Perfect. So that's what a network diagram looks like for some of these service industries. So what we're going to do now is take a look at the takeaways for this. So one, management. Anytime we've got changing locations, management is going to be particularly important when it comes to choosing a solution. And because everything is housed in the orchestrator, which is in the cloud, anybody who has access to it can access it from any device that has access to the internet. Communication. The site-to-site VPNs. So no longer did speedy site cleaners have to initiate and create that VPN every single time they had a new job site. They just set an SD-WAN box that's going to provide that with everything else in the network profile. And redundancy. We took those permanent locations and introduced a level and layer of redundancy and resiliency that previously was not there. So then the Freewire solutions. One, this is what we do at Freewire. We have 4 different SD-WAN providers, and we have taken a look over the last 2.5 years to vet them and choose the 4 best ones that we consider to cover every single use case. So that means that because we're not an actual provider of SD-WAN solutions, meaning we don't manufacture the product, we just implement it, we have a truly unbiased solution / evaluation and delivery of the product. Like we had mentioned earlier, not all SD-WAN solutions are the same. In fact, they're all very unique, and they have different flavors and takes on how they address similar issues, but in different ways. And one particular SD-WAN solution that works great for customer A will not work great for customer B, and really needs to be SD-WAN solution number 2. And because we have that deep base of knowledge and understanding of these different types of SD-WAN solutions, we can provide the consultation and observation for that specific end customer. Over here at Freewire, with all of our solutions, we provide 24/7, 365 NOC support that's manned, located here in Beaverton, Oregon. So we don't just sell a solution and then walk away. We sell a partnership, in that we're going to go ahead and monitor and provide consulting on an ongoing basis with the end customer. We provide complimentary network evaluations. So we really encourage individuals to just start an informational conversation with an end customer, and where we come in and talk about SD-WAN from a whole, educate them, and see how it might fit into their network. And finally, once we've identified that it's going to be a good solution for that customer, we promote pilot programs. So the proof is in the pudding. So we do POCs all the time, in which we will actually set up a 30-day trial where we extend the SD-WAN solution to that customer's network and make sure that everything goes smoothly. Now I know we're right on time, so I wanted to keep this last 10-15 minutes and gear it towards questions, as I'm sure there are quite a bit. So I'm going to address a few that have come up already. And the first one that I'm going to take a look at is, does SD-WAN work with a single connection? So yes and no. That's a great question. SD-WAN, if you're going to get the most out of it, requires at least 2 connections. However, it still can provide some benefits to a single connection-based network. Most notably, that's going to be in the form of bidirectional prioritization. So both prioritization of in and outbound traffic. So bandwidth connection can be alleviated, but what you're not going to get in a single connection network when you overlay SD-WAN is going to be the traffic steering, because there's only one transport path. You'll also get the network management and monitoring perspective, as well as the automatically generated VPN, but really it's best practice to incorporate 2 connections, at least 2 connections when possible. All right, we've got a second question here. What is an example of a specific cost savings that you have seen with an SD-WAN solution? Yeah, absolutely. That's going to be one of the questions that's asked immediately from most IT networking teams. How can we save money on this? How can we increase our ROI? So to give you guys some hard numbers and examples, let's take a look at a retail case study and a retail opportunity that we did. They're running MPLS over T1s, and that ranged from $400 a month up to over $1,000 in some locations. So if we stick with the $400 a month over T1, what an SD-WAN solution would do is we would recommend that you replace the MPLS with 2 public internet business class connections. So a cable and a DSL. And those are going to run you on the lower end anywhere from $70 a month to $100 a month for the business class cable, as well as anywhere from $40 to $100 a month for the DSL. So we're looking at right around $160 a month for the connection bandwidth. And to give you an example of the cost of an SD-WAN solution, it's probably for that level of bandwidth going to run you around $100 a month. So you have a fully baked delivered solution for $260. So about $140 cost savings on what used to cost $400. And what you're giving that and the customer is going to be 1, more bandwidth, ease of management and deployment, as well as no more single point of failure, and ensuring the same quality that you'd expect over MPLS. So really, at least 40%, which is a large number. It looks like I've got one final question here that was asked. Can you explain in more detail how the systems ensure VoIP traffic can run smoothly across public internet connections? Absolutely. So this is going to require us kind of opening the hood to these various SD-WAN solutions and diving a little bit deeper. So really, when we're talking about ensuring QoS, that's specifically asking, bandwidth correction and optimization. Now, each system does this differently, but they all kind of have similarities when it comes to the foundation. And that is that SD-WAN solutions are going to monitor for connection and application health across all the different connections on an ongoing real-time basis. So the systems are proactively monitoring these connections for jitter, packet loss, latency, total throughput, application health. And depending on those metrics that they gain, they're going to route traffic on either a per packet, depending on the solution, or per flow-based session. So if connection 1 is experiencing 10% packet loss, it's going to steer traffic over to connection 2 unless connection 2 is experiencing a worse metric, maybe huge latency, at which point, depending on the solution, it's going to bond, replicate traffic, but it's going to take a variety of circuit remediation techniques to correct that bandwidth. So 1, we've got connection correction, basically, and 2, bidirectional QoS. So control and prioritization of both in and outbound traffic. So not only are we correcting bandwidth, we're making sure that prioritization is applied to mission critical applications, because that's actually the only thing that matters for these operations. We don't need customers to have employees have access to Netflix right away, but we do need their POS systems and their VoIP phones to take precedence all the time, or whatever other mission critical applications they have. So we correct the bandwidth, and we also apply true prioritization to both traffic type and applications on an ingress and egress basis. So great question there. Let me see if there's any other questions that have been answered. All right, I'm scrolling through these. And it looks like we've addressed most of them. So what I'm going to do is this video has been recorded, and everyone will have access to it. And what we'll do for anybody that hasn't had their question answered accurately, we will go ahead and follow up with either an email or a phone call to talk on a specific basis. Perfect. All right. Thank you, everyone, for joining us today. We appreciate everybody taking the time out of their days to hop on this call. And like I said, we'll go ahead and get back to everybody that had an unanswered question with a specific email and phone call. Thanks, everybody. Bye.